Hello, everyone, and thank you for visiting my session about breaking down CGMES barriers and how OpenCGMES might help you to solve some challenges around CGMES. I will shortly introduce myself, and I'll give a short introduction into CGMES and the technologies behind it. We'll tell you about our first journey with CGMES, the detour. Then we will come to some parsing headaches, validation nightmares, integration bottlenecks. And then I would invite you to join us on our next journey with CGMES using all W3C standards. And at the end, I will introduce OpenCGMES as a new project. So I'm a division manager at Soptim, the Department of Grid Control Systems. I'm a software architect, open source advocate, and active contributor to the Apache Jenna project. The Common Grid Model Exchange specification has a long way. It's based on the Common Information Model, CIM, which was developed in the United States mainly at the end of the 90s, early 2000s. So, and in Europe in 2008, the UCTE, which was the predecessor of ENTSO-E, decided to replace their old format, which is basically an ASCII format for punch cards, by CIM. The goal was to have a harmonized and interoperable representation of the entire European electricity grid. The relevant versions are 2.4.15, which has been released in 2014, which should be the standard today. And in 2021, they released version 3.0, which is not widely accepted yet. So today, there is not a single ENTSO-E process in daily production that relies on CGMES. So what's wrong with CGMES that we still rely on punch cards? Okay, first of all, to everyone who doesn't know it, it's the relevance. We need it for the European merging function to merge all the European grids together and all follow-up processes. For system operation processes, grid development studies, redispatch. And the ENTSO-E is constantly developing new extensions to CGMES, which are called the network code profiles. They are used for, or shall be used, for coordinated security analysis, coordinated capacity calculation, outage planning coordination. So it's relevant for all European TSOs. It's relevant for the 6 European RCCs, and it will be relevant for most DSOs in Europe. So, I'm sorry, but I first have to start with the technology layers. Because when they started to develop it, or when they developed it in the early 2000s, it was developed as ontology, with the goal to support linked data and the semantic web standards. So, the first 2 layers are basically UML models that model this ontology. They tried to model the real world, everything that's there in electricity grids, from transformer to lines to breakers to power plants, as a huge canonical model, then broke it down into application profiles, and then from this they derive technical artifacts that we can use today. This is profile schema and instance data. So when building software, we can focus on profile schema and instance data, luckily. So we have RDF schema, which describes the semantic structure, which is classes, inheritance, attributes, data types, relations, and so on. Then we have SHACL, which is a validation language for RDF data. And it all relies on RDF itself, which is a graph data format for representing information in the web. It has several serialization syntaxes, but unfortunately, CGMES comes with its own serialization syntax, which is SIMXML. All libraries that implement these standards work with graphs. It's something one should know. And in my opinion, and that's very personal to me, is there is a missing standard. Because the RDF standard, the W3C standards are used to describe the model and the data, but how to work with this data is open to specific implementations. Openness is great. However, there is a complementary standard which should at least have been a recommendation, and that's SPARQL. It's a query and data manipulation language for RDF graph data. You may think of it like SQL, but for data sets with graphs instead of relational database tables. So, for example, if you have a schema, you can query all attributes of a specific class, including the parents. When you have these SHACL shapes, you can search for all rules that target a specific class. When you have the validation results, you can filter for severity. And when you have instance data, you can get the aggregated wind power generation in a specific region. You can even update instance data to set a new step changer position. But unfortunately, that standard is not even, SPARQL is not even mentioned in the documentation and the standard of CGMES. So, in my opinion, there are really ingenious parts when CGMES is used the right way. So, for example, it supports domain-driven design because there is already an ontology. So that ontology covers much of the needed ubiquitous language. They already designed some profiles, and the concept of these profiles can be regarded or used as bounded contexts. And you have one set of vocabulary and semantics, from schema definition over validation rules to querying and data manipulation. So this has a potential to bridge the gap between electrical engineers and developers. It's also very great for model-driven software development. So why is this combination of standards not used and mentioned, and why is SPARQL not used to explain concept and share knowledge today between engineers and developers, for example? And one main reason might be the broken toolchain at SIMXML. So in 2015, my first journey with CGMES began when we had to convert a TSO SCADA punch card output into a valid CGMES grid model. We've been given some documentation, example files, all these artifacts. But the documentation contained one most misleading piece of information, which was that SIMXML is a proper subset of standard RDF syntax and can be read by available RDF deserialization software. Well, we will see about that. So we knew little about the technologies, about ontologies, RDF or OCL. So we tried multiple parsers. If we got an output of the parsers for our SIMXML files, we were not able to use the output. We tried to validate instance data using RDF schema. There's no library support for that. As I know today, validation is nothing the RDF schema is meant to do. So we looked for OCL parsers or validation libraries and found exactly nothing. So we decided to just disregard everything and stay with XML schema, definition files, generate our code from there, parser, serializer, and rewrote the validation rules from OCL as part of the application code. So we succeeded, and to my knowledge, many projects followed a similar path, just disregarding all the W3C standards around RDF and going forward with the XSD schema definition. But in my opinion, there is a better way. So, were we just too stupid to properly work with CGMES and XML? Maybe, but the headaches and nightmares made us curious too. So we became interested in the world of RDF graphs, dug a bit deeper, and we learned what is wrong with SimXML years before these gaps were officially listed and documented. So one possible root cause is IEEE published SimXML in 2003, where RDF XML has been published in 2004, 1 year later. And there is an interoperability report around CGMES. The version from 2023 states, SimXML has some gaps compared to RDF XML. It can be solved by using JSON-LD rather than trying to fix SimXML serialization. Okay. And having a look at the IEC specification, you can see that you have to replace underscores with one UUID in your parser. That's the concept of the difference model introduces a new RDF parse type statements, which is invalid syntax and breaks parsers. And also the concept of difference models requires multiple graphs in one file, which is not how RDF XML works. And there are the missing data types. The IOP report from 2024 states data types are essential, but they are not exchanged. Okay, and it states there is no open library to enhance the data. And they list 3 possible ways to solve this. Change the serialization. Okay, away from XML to JSON-LD, that's the way the ENTSO-E is going. Second, provide an open library. And third, have each vendor figure it out on their own. We are stuck with option 3. And I think from the experience, since the 2014 version is not production ready yet, the switch to JSON-LD will take years. So we need that open library today. So to give you a perspective of how the world can be if you combine all the standards, let me tell you about our second journey with CGMES. So this time we had the task to build a redispatch optimization platform for the 4 German TSOs, which had to be CGMES ready and had to work with, for example, day-ahead processes, which is 24 hours, with grid data of all European TSOs. So this time we converted SimXML into valid RDF. We used RDF schema to build generic user interfaces to edit any data that's described as a schema. We used SHACL for data validation. We used SPARQL everywhere, also in APIs for external components built by partners. We even created our own SIM profiles for additional data. So we learned that RDF and SPARQL can be slow, but we fixed it by using Apache Jena in-memory graphs. And we had to find a way to come away from that profile perspective to a data set perspective with named graphs, with fixed named graphs, to make the SPARQL queries independent of the context, so that we could reuse them everywhere. And for the software architects, working with graphs and the concept of difference models enabled us to implement event sourcing with CQRS effectively. So, why OpenCGMES? First part of it is an open library to perform the parsing and mapping of data types. So, ENTSO-E, there it is. Second, it provides a multi-graph perspective to SimXML data, similar to how it is planned to be with JSON-LD. And it helps a lot with your queries. And for us, we need to share SPARQL and SHACL between customers, partners, engineers, and developers to collaborate better. So the ones of you who might have looked yesterday at the repository, it was not online, today it is. Yeah, it's still under development, so, but the parser is there. It solves all parsing challenges that we know of. So, and we've about 10 years of experience. It's tested. It also supports custom profiles. It's not hard-coded against anything from the ENTSO-E. And it's highly optimized for performance. So maybe if you have an RDF parser currently that you use, you can just use this and replace your old parser, and it will most likely be faster. We also provide a web application, which is not in our repository yet. It's still under heavy development. But I will show you later that you can upload data, query data, and validate data. So it's designed to be a suite of tools. So first of all, there's this Java library that works well in conjunction with Apache Gina, but maybe it may also simply be used as converter. You put in sim XML and get out valid RDF XML. The web UI, and on our roadmap are also command line interface, REST API, gRPC endpoints, export of JSON LD. And this week we are starting to use AI to generate SPARQL and SHACL from text and vice versa, because the RDF schema already contains all the ontology information. So that's the context we give the large language model to provide us with better output for our SPARQL queries. And but that's some kind of research and development currently. Okay, in this tool, you may upload schema, models, and SHACL files. So I will just use RDF schema from ENTSO-E for CGMES 3.0. It's uploaded and ready, including file header profiles. Then I will drop in the SHACL files. And as you might see, they are available now. But we still need some grid data. Thank you, ENTSO-E, for providing the conformities, these test configurations. So that's not what I wanted. Okay, now I have two grids. And I can start to write a SPARQL query, which so I would like to keep it simple, but not boring, excuse me. One wind power generation is not much. So this is an example of how easy it should be. Just have your sim file, drop it there, query it. In this case, yeah, we have a few wind power generating units, about 400 here. And I told you about the use case to get the aggregated wind power per region. And this is something I prepared for. So that's how easy it should be. So it's due to the example naming here, but this is the region name, number of wind generating units, aggregated active power, and aggregated reactive power. So, and about SHACL validation, we have too many rules here. Let's just select a few. select our SSH profile, and look for the validation result. Okay, successful but boring. Yeah, here we are. So this is how it should look like. It should be easy to just take the files that the ENTSO-E provides us with, analyze your data, validate your data. So, yeah. That was it from my part. Thank you very much for your patience. Any questions?
I would like to provoke a little bit for your honest opinion. So we have the context of CGMEs. We cannot break all of the context. But when we're looking at graph database, we're looking at SPARQL. Is that an overkill for the real problem we need to solve by utility? If you look at the relation of the data, most of the time, traditional relational database would make it work as well. Do we really need to go to the level of graph database solution and even graph type of query language to solve the problems in its core?
Sorry, could you repeat the last part, please?
So do we really, is there a mandatory reason that we need to use graph database to solve the CGMES problems? Or the root of the problem, not CGMES, but the utility data exchange problem?
Okay, it's you clearly do not need that. There's a software stack to go around it. But these are the complementary standards from W3C that all work pretty well together. And we have an amazing performance, for example. So for us, there is no need for another choice. For example, with this redispatch platform, we had our partner, FGH, develop the optimization algorithm. So we had to define an interface between us and them that would include all the grid data and all the additional data for them and their calculation course. So we have one gRPC call which just takes SPARQL queries. They select the parts they need from the model depending on the context and the type of calculation they do. So no integration hassle with our partner there.
I have no doubt about the solution. Challenging the design.
Yeah, it depends on where you are and how much assets you've already built up. So it can help you just solve your parsing problems at the beginning, or you go the full way and say, okay, in the future, SPARQL would be a great alternative.
Do we have alternatives from industry for CGMES today?
Yes, and I don't disagree. There are existing standards, and as I said, we use it for in-memory, but when we store the data, we use relational databases. So, because also some of the graph databases were mainly developed for the semantic web and things like that, and do not match our needs. Yeah.
Thanks a lot.
Okay, thank you.
Sorry, I had one more question. If you, first of all, thanks for your presentation. Your painful journey matches my own, so I recognize a lot of the things that you mentioned. One question, one comment. Maybe the comment is, I'm working on trying to have CGMES adopted by DSOs a little bit more because it's a TSO thing. And so if you are a DSO and thinking about this, skip the whole SIM XML part and go right to the W3C standards because you have off-the-shelf tools that can work with it as opposed to proprietary stuff, or not proprietary, but very limitedly scoped to our industry. So that was the comment. The question is, you mentioned SPARQL as something that they should mention as a standard, and that's not very clear to me why, because My assumption has always been that the sim provides, like, nobody who publishes an ontology also says you should use SPARQL to query the data. It's just the obvious choice once your data is in RDF, but you could go ahead and write your own parser if that's what you, or your query engine if that's what you want.
Yes, but they publish the standard with RDF schema to communicate about their ontology. They publish SHACL rules to communicate about their validation rules, but they don't use the power of SPARQL to communicate knowledge.
I mean, they do to some degree because some of the SPARQL, some of the SHACL shapes involve SPARQL queries for complex validation. But still, what would be, like, what knowledge would you convey with a query? That's the part that just...
Okay. It's mainly about there is no technical abstraction layer like a relational database model where you have everything with underscores and T in front like table or things like that. So when you want to query a database, you go to your database expert and they tell you which part of your domain model is you can find where in your database tables.
Right.
That's simply not needed when you work with SPARQL and RDF. So the engineer, the project manager, the database engineer, front-end developer, they can all speak about the same concepts and reuse the same queries. TSOs could interchange information about their models using SPARQL. Hey, I built a great query to sum up or to find some...
I mean, you could share queries, but they target a very specific use case, not like a very specific query by definition. Like they're not reusable in that sense, right? I mean, I could give you my query, and if you happen to have the same questions I did, then it makes sense to use that query. Whereas with an ontology, if we're trying to describe the same thing, that makes sense to reuse to me. But we'll talk about it afterward. Thank you.
Yeah. Maybe.
So we also worked on the RDF using Neo4j to exactly do the same problem that you try to solve using this thing. My question is, do you really think that now, considering that we have so many tools that can very robustly import CGMES, that we still need such validation tools with SHACL and SPARQL?
So first, we see that in all our projects, our customer use the ENTSO-E validator, which uses these SHACL rules to validate incoming data. That's the first step, always. So, and in our project, we develop our own profiles. So we have our own SHACL rules. We can even have a RDF schema without SHACL files and generate SHACL files from there. So SHACL is our first validation step. Even, for example, in ETL transformation, when we have a special sim model and we want to export standard CGMES, we first validate our input model using SHACL, then perform our transformation, and then validate our output against SHACL. So it's a great tool. And it works well with RDF.